which you have is going to decay as a function of time. The forced response will sustain based on the input you have applied. So any transient system is going to have, any system in transient domain has natural response and forced response. So the V of t, so the V of t is going to have a natural response and forced response. Both are functions of time. So this, as you learned in the classes, this also can be represented, the total response of the system can also be written as zero input response plus zero state response. So zero input response means the circuit has resistors and capacitors or inductors, all of them. Whenever you make your input zero because of the initial current in the inductor or initial voltage across the capacitor, and there is a response which is going to decay as a function of time or sustain based on the type of inductors, the elements you have. Similarly, zero state response means you already have applied input to a circuit which has inductors, capacitors, resistors, but initial conditions in the system is zero, means initial current in the inductor or the initial voltage across the capacitor is zero, and the response corresponding to it is called zero state response. The same V of t can be expressed as this, or V of t also can be expressed as a steady state response plus transient response. Okay, so the transient response is, in general, which is going to die with the function of time, is natural response. The steady state response is going to be forced response. But the 2 points what you have to note down is the natural response actually is not equal to zero input response. The natural response depends upon both the input and initial conditions. That's what you have to keep in mind. So based on this, the natural response of the system does not depend on the input, applied input is false. And match the following. The steady state response is forced response and natural response is transient response. So this is the correct answer. Are these clear to you based on the class you learned? And
yes, sir.
Okay. Okay, great. Okay. Now let's try to solve question by question. First question. The first question, you had an input to an RC circuit, which is 1 volt, which is from long time. Now what happened was, suddenly the input has become 0. Now, if you see the voltage across the capacitor at t equal to 0 plus is 1 volt, and it's going to exponentially decay. This is what we learned in the week 9 classes. That response can be expressed as, just a second. Yeah. That response can be expressed as the initial voltage in the capacitor multiplied by e power minus t by tau 1, where in this case tau 1 is R1 C1. I'm calling this as R1. Okay. Now this voltage is being applied here through an amplifier. Now, since from the amplifier classes you learned that this voltage V0 e power minus t by tau 1 multiplied by the gain of this circuit, which is 1 plus RF by R1, R in, let's call, this is RF, this is Rn. This whole thing is 4. So basically the voltage on this is 4 times V0 e power minus t by tau 1. Is this step clear to everyone?
Yes, sir.
Okay. Now, This voltage is being applied to an RC network with a different time constant. This is R2C2. Let's call this an R2. Let's call this as a C2. Now, what happens to output? That's given. The output looks like this. But from the class, we learned that if I write my differential equation, I can express it as T times d V out by dt plus V naught is equal to Vp e power st. If this is the form of a equation I have, where Vp into e power st is the input, that's what it is in our case. This is a differential equation. This differential equation has a solution, which is V out. V out is equal to Vp e power st divided by 1 plus s times tau plus a times e power minus t by tau. Just a second, I'm sorry. Yeah. E power minus t by tau. So for this differential equation of this form, this is going to be the solution, which we learned in the class. Okay. Now, if this is a solution, we can clearly map that. Here, the point here is the input what we are applying here is Vp e power st, right? So keeping that in mind, if you see here, we wanted to solve what is V1, what is tau 1, what is V2, what is tau 2. Okay. Now, the first thing is, let's try to see what is S here. Anybody? What is S? S here is the minus 1 by tau 1. So if I write a solution for this V out 2 based on this, which is Vp, which is V naught, e power minus t by tau 1 divided by 1 minus s tau 2 by tau 1 plus a times e power minus t by tau 2. See here, the s term here is this minus 1 by tau 1. That's what I replaced. The tau is tau 2 because this is main network. Is this response clear to all of you? What we have written here?
Yes, sir, it is clear.
Yeah. Now, so if I substitute t equal to 0, what do I get is my V out 2 at t equal to 0 is V naught divided by 1 minus tau 2 by tau 1 plus A. Right? What is V out 2 at t equal to 0? That is 4 volts. You see here. That's 4. So 4. What is V naught? V naught is 1 volt because initially I have a 1 volt here. 1 minus tau 2 by tau 1 plus A equal to 0. Okay, I already know what is tau 1. Tau 1 is equal to 1k 1 microsecond, which is 1 millisecond. Tau 2 is equal to 1.5 milliseconds. So if I substitute those numbers in that, I can get what is the value of A. Okay. Now, so what is so interesting here? So if I know A is same as V2. A is same as V2. You compare here term by term. Tau 2 is, A is, right? And also if you compare, the term V1 is equal to V naught divided by 1 minus tau 2 by tau 1, where V naught is 1 volt. That's it. We got everything right. Is this clear, or do you want to repeat anything else?
No, sir, it's clear.
Yeah, others? Anyone in the class wants me to repeat? Okay, great. Let's go to the next problem. Okay. In the circuit given below, shown below, the current through the inductor at t equal to 0 is given by 2 milliamps and the frequency is 10 power 3 radians per second. The output for t greater than 0 is of the following form. Yes, this is the form. Now we wanted to find what is the value of alpha, what is the value of beta, what is the value of pi, and so on and so forth, and tau, right? So to solve this question, first we need to write one KCL equation on this and get it to form of this. Because we know the solution for this is this. Okay, let's try to solve it. So this voltage is VL. Okay, the current in the inductor is current in the inductor is 1 by L integral VL dt plus VL minus VS divided by 1 kilo ohm equal to 0. Do you all agree with this equation?
Yes, sir.
Now, if I differentiate this equation, what I get is, okay, let me call instead of 1K here, let me call as an R. R is a parallel combination of 2K in parallel with 2K. So VL by L plus 1 by R times d by dt of VL minus d by dt of Vs is equal to 0. Okay. Now, if I rearrange this this equation, I can say that this is L by R times d by dt of VL minus, plus VL is equal to L by R times d by dt of Vs. Do you all agree with this equation? Can somebody please confirm? Did I make any mistake? Correct, right? Yeah, okay, thank you, clear, thank you. Yeah, Preetham, is it okay, clear?
Sir, last line, can you explain again the last line?
Okay. So I rearranged this line, that's it. So d by dt, L has gone there, L by R d by dt, VL is equal to L by R d by dt of Vs.
Okay, sir.
Yeah. Now, when you excite an RC or RL or RLC network by a cos or a sine or an exponential, the result is also going to be in the form of cos, sine, and exponential. So let us assume that I have applied a signal Vs of the form Vs is equal to Vm e power st. We call Vp before Vp e power st. If I excite by this, the response of if I assume that my Vs is of this form, then I can say that L by R d by dt of VL plus VL is equal to L by R So the differentiation of this is Vp times S times e power St. Do you agree with this? If I assume that my Vs is this form, then that's the solution.
Yes, sir. Clear.
Okay. Yeah. Now, if you really see it, this whole thing, what I have termed, is actually a constant. L is constant, R is constant, Vp is constant, S is also constant. It's also either a time constant or a frequency 1 by tau, something like that. So this all is also constant. If you really see it, this is same as this equation what we had. Tau d out over dt v out Vp e power st. That form only we have finally ended up. Right? So we have a solution for this already. Only difference is before the Vp was Vp, now the Vp is this. Do you agree with this statement? So let's call this as some Vp1 or Vp dash. Okay. Now the solution of this is VL Vp dash e power S T divided by 1 plus S times L by R plus A e power minus T by tau. This is the solution. Vp dash, instead of Vp, we have Vp dash. Do you agree with this?
Yes, sir.
Okay. So that's it. So basically in this thing, this I know the solution already. That solution is given here. So in this, if you really compare, the exponential e power minus T by tau is multiplied by beta, which is A. Okay. But actually, what we applied signal was not Vp e power st. The real Vs, what we applied was in the circuit is the real part of Vp e power j omega t. Do you agree with that? The real part of Vp e power j omega t is Vp cos omega t. That's what the real
Yes,
signal
sir.
is.
Yes, sir. Yes, sir.
It means the solution of this equation is you have to take the real part of VL. In this equation, S should be replaced by j omega and take the real part of it. So the VL is real part of Vp dash e power j omega t divided by 1 plus j omega L by R plus e power minus t by tau. That's the solution. Okay. Well, I want to get the real part of it. So let me write the real part of it. So you keep this as a part of this story, but this is not exactly applied to this circuit. It's general story we wrote here. In this circuit, what we applied Vs was this. Real e power Vp e power j omega t. Okay, what is the real part of it? Vp dash. Okay, what is Vp dash, by the way? Vp dash is L by R Vp j omega. So Vp dash is L by R V peak times j omega multiplied by e power j omega t divided by 1 plus j omega Lr plus e power minus t by tau. So the real part of this is our interest. So what you can do is you can multiply denominator and numerator both by 1 minus j omega L by R. Then what happens is L by R Vp e power j omega t has two parts, cos omega t and sin omega t, right? Okay, j omega multiplied by cos omega t plus j sin omega t divided by 1 plus omega square L square R square multiplied by 1 minus j omega t. 1 minus j omega L by R plus a e power minus t by tau. So in this portion, we have to take only real portion. Real part only you have to consider. So the real part is, if you see, this is j omega. Cos is getting multiplied by j omega. Getting multiplied by 1. So that becomes imaginary part. But this j omega multiplied by that j omega becomes imaginary part, real part. So only take the real portion of it. That real portion of it is going to give the solution. That you have to compare with this real part here. Then you will get alpha and beta. Is this clear?
Yes, sir, clear. But the question is too difficult. That means a lot of calculations involved in this question.
Yeah, yes. True. So a lot of calculations are there, but you have to solve it. So you basically get a cos omega t sin omega 2 terms you are going to get. That cos A, cos B you have to express as one cos term. Then you have to basically find it. Okay. So another thing is also here. The initial current in the inductor is given, not the initial voltage across the inductor. So how do we find it? That is, so this is initially 5 volts. There are 2 resistors in parallel, which is 1 kilo ohm. And initial voltage across the capacitor inductor VL0 is going to be so VL of 0 you wanted to find, which is equal to, this is 5 volts and the current in this is 2 milliamps. So 5 minus 5 volts, 2 milliamps, and there is a 1 kilo ohm resistor there. So that is 2 volts across it. That gives you 1 volt. 5 minus, 3 volts. So VL of 0 is 3 volts. That information you have, and you have a omega. You equate term by term there, then you'll get all the constants, beta, tau, pi, and alpha. Okay? Do you want me to repeat any part of this question? Anyone in the class? Anyone? Pritam, is it okay now?
Yes, sir, it's okay.
Yeah. Okay, let's go to the next question if you don't have a doubt. So we see the trick here is simple. The trick here is, the trick here is you have to always get the differential equation in this form. Tau dv by dt, dv naught by dt plus v naught multiplied by e power st. You have to get this form and you know the solution. See, if you're only applying a cos or sine, you have to take the corresponding real part or imaginary part. Or you can express, if you have a sine, you can express it as cos omega t minus 90 degrees. And this minus 90 degrees is going to be added at the end of the day to the output. Okay. Let's go to the next question. Okay. This question 3 is, question 3 is this. Let's write one KVL here again. Let's call this as Vs. V out minus Vs by R1 plus C1 times d by dt of V out minus Vs plus V out by R2 plus C2 times d by dt of V out is equal to 0. Okay. Is this equation okay for you all? Can somebody please confirm?
Yes, sir.
Yeah, this is just a KCL on this node. Okay. Now let me try to combine all the V out terms corresponding to resistors, corresponding to capacitors, and so on and so forth. So if I do that, I can say that I have C1 plus C2 d by dt of V out plus 1 by R1 plus 1 by R2 times V out is equal to C1 d by dt of Vs minus Vs by R1. We can group it like this. So if I say that this is C equivalent, if I say this is 1 by R equivalent, I can say that tau is equal to R equivalent multiplied by C equivalent. Then I can rewrite this equation as tau times dV naught by dt, dV out by dt plus V out, because this R equivalent is gone here and there, both sides, is equal to R equivalent times C1, this is also plus C1 dVs by dt plus Vs by R1. So this is a final equation. But the point what you have to note down is, again, you have to think that your Vs, what you are going to apply is, let us say, Vp e power st. Then it can be written as tau d by dt of V out plus V out is equal to R equivalent. So Vs by R1, which is Vp by R1 times e power st plus C1 d by dt of Vs, which is Vp s e power st. Do you agree with this? I didn't do nothing. I just substituted Vs equal to Vp by e power st. Okay. Now rewriting this back again, R equivalent multiplied by Vp by R1 plus C1 Vp s times e power st. This is going to be your new Vp dash. This equation is exactly same equation what solution we had before. Tau times d by dt of V out plus V out Vp dash times e power st. The solution of this equation we already have, right? Is it okay? Clear? Pritam, is it okay?
Yes, sir.
Yeah. So the solution of this equation is, as we just learned, as Vp dash multiplied by, what is that? E power st by 1 plus s tau. Plus some constant times e power e power minus t by tau. But the point here is there are no initial charges in the system, so I can cut down this term. I'm only left with this. So in this, you substitute the Vp dash, replace S by j omega, Vp by 5 volts, omega by corresponding frequency, and take the imaginary part of it. Then R, you can express sine omega t as cos omega t minus 90 and take the real part of it. You will get your answer. Okay? Is this clear?
Yes, sir.
Great. Let's go to the next problem. So similarly, the circuit shown below omega equal to 10 power 2 radians per second and the output response is given by this form. Then there is no initial charge in the system and we wanted to find what is Vp and pi, two values. When R is infinite, when R is 10 kilo ohms. See, when R is infinite, it's simply a capacitive division, right? Whatever is your input voltage, it's going to become by 2 by 2. That's it. But if it's 5 sine omega t, if R is infinite, I'm going to get 5 by 2 sine omega t. Exactly same. So pi is going to be 0 and Vp is going, the V out is going to be 2.5 volts. So this guy is 2.5, this is going to be 0. Is this clear?
But in the solution, it is given in the range 0.9 to 1.1 Vp.
One second. Did I make some mistake here? No, the answer should be between, the answer I gave is correct only, 2.5 and 0 degrees. This is correct. The solution also says same, but what is your doubt?
Sir, in the solution, that means actually
in the form, in the class, here you are telling week 10.
Yes.
Assignment, practice week 10, quiz week 10. Okay, quiz, right? You are talking about quiz, right?
Quiz 10, yes.
Which question is that? This question, right?
Question number 11.
This is wrong. So this fellow is 0. This fellow is 2.5. So range is wrong. That's what you're telling?
Yes, sir. Actually, I put 2.5 but got 0 marks for this question.
Oh, so we will correct it then. We are sorry.
Okay.
Okay.
Okay, sir.
I'll note down this. Thank you. Just let me note it down in a page. Yeah, sorry. See, unfortunately, we don't have a lot of TAs. We have only very few people who are handling too many things. So that's why things are going wrong. Question. What? Which question is this? Question number
11. 11.
11. Okay. Q11.
Quiz 10, question number 11.
Question 11. Answer. I have noted down. We'll correct it. Okay. Thank you. Okay. Let's solve the other one, which is difficult part of the story. Again, in all these questions, what you have to do is simply, there is a natural response, there is a forced response. The natural response will not be there if there is no initial condition. You are only have to worry about the forced response. Okay. Okay. With this, if I write a KCL again here back the way we have learned right now, so C dV out by dt plus V out minus Vs by R plus C d by dt of V out minus Vs equal to 0. Okay. Clubbing terms 2C dV out by dt minus plus V out by R is equal to Vs by R plus C d by dt of Vs. So rearranging the terms, this becomes 2RC d by dt of V out plus V out is equal to Vs by R plus RR cancels Vs. So RC d by dt of Vs. Do you agree with this equation? This is an equation describing this network.
Yes, sir.
Okay. Again, the same story. What you have to assume is you can substitute Vs as e power st. Then again, the solution, again, if I substitute Vs equal to e power st, sorry, Vp e power st, then I get 2RC d by dt of V out plus V out plus equal to Vp e power st plus RC Vp yes e power st, the derivative of Vp e power st. Now I can Vp e power st, sorry, take e power st out of this whole business. The Vp plus RC Vp it is, which is Vp dash. That's it. The solution we already have. The solution is Vp dash e power st divided by 1 plus s tau. That's it. The tau is 2RC in this case, and s is j omega, and you have to take the imaginary part of this whole equation. You have to multiply numerator and denominator by 1 minus j omega, take the imaginary part of it, and equate term by term, you get the answer. Is this clear?
Yes, sir, it's clear.
Okay. Okay, let's go to the next step. For the input V in equal to B sine omega t, the system generates of the following form. Identify the natural response A. Identify the forced response B. Simple question. Shall we go to the next question? Is it clear?
Yes, sir.
Great. Oh, we are done. Oh, we have a last question. Yeah. Consider the circuit above and the output VOT of this form, find Vp and pi. I think same story, which we just solved it right now, but exactly same thing, you have to repeat the same story. I think that's a much easier question than the others. So any of you want me to repeat any part of these questions, I'll repeat. Otherwise, the 10th question is much simpler than it's same as you can think of any of the questions.
I have one doubt in assignment 1. Can you please discuss that question? Assignment 1.
Sure. We'll go back to that. Let me first ask others have any doubts in this, then we'll go back to that. Yeah. See, I request you to kindly attend Monday Tuesday and Wednesday next week. Again, I'll take 3 days classes in which I'll discuss assignments 12. This is 10, right? This is 10. Yeah. On
Yes.
Monday, I'll discuss 11, 12. And on Tuesday and Wednesday, I'm going to solve some problems which will help you to solve the final question paper. Exam
Yes,
paper.
sir. Yes, sir. That will be very helpful.
Yeah. Exam is in which day? Exam is on
23rd, Saturday, 23rd.
Saturday, right? So that
Yes.
whole week, right? Monday, Tuesday, Wednesday, 3 days I'll take classes, 3 or 4
Okay.
days. You
Okay,
all can, I'm going to help you to solve a lot of problems because the exam paper I feel is relatively tough. So if you can attend those sessions, it will greatly help you. So kindly inform your friends also to attend those sessions, okay? Yeah, if you solved all the assignments and attend those sessions, you should be able to easily crack the exam. Don't worry about it. It's tough, but you can able to solve.
Thank you.
Okay. Okay. In general, the 40 to 50% of the paper is relatively easy. You can easily do it in half an hour, 45 minutes. Other part of the thing is you have to really use your head, like these questions. It's really tricky. Yeah. So we'll solve some tricky questions in the coming classes. Okay. Any other questions from this quiz, this assignment? If not, then we'll go back to the. Okay. Let me just go to week 1. Which question you have doubt?
Sir, please down. Sir, one sine wave, then a straight line part like this. Actually, question number 14 in assignment.
Okay. Just
This one,
one?
sir, this one. Yes.
Yeah. So what is the question? Shall I solve it or what is
Sir,
it about?
actually given answer it is asked in milliampere. IL at 1.5 second in milliampere, but actually given answer in ampere, right? Actually, given answer in your solution, it is in ampere, I think. Can you please solve it?
So, okay. You feel there is a mistake in the answer key?
Yes, sir. Yes, sir.
Okay.
Maybe I am also wrong. Maybe.
Okay, let me solve it then. Don't worry. Okay.
Yes, sir. Yes, sir. Thank you.
Current through the inductor AL at 1.5 milliseconds E. 1.5 milliseconds is dash milliamps. Assume the curve in the plot is between 0 and to be the sine function. Okay. So basically the voltage is given, current to the inductor you want to find. So this basically 1 by L integral Vx dt is I.
Yes, sir.
What is 1 by L? Okay,
and
this
sir,
is minus
and
infinite to t.
initial current is given also.
Yeah, this is minus infinite to t. 1 by L minus infinite to 0 Vx dt plus 1 by L 0 to t Vx dt. The initial current is given how much? 0.5 milliamps.
0.5 milliamps.
Yeah. Plus 1 by L integral 0 to t. The function given is sine function. Okay. So this 1 sine omega t. What is omega? Omega is equal to 2 pi by t. T is 2 seconds.
Yes.
So half period is 1 second, 2 periods is 2 seconds. So
yes,
omega is basically equal to pi. So this is sine pi t dt.
Sir, it is up to, sorry sir, this is up to t is equals to 1. And another part, a straight line between 1 to 1.5 milliseconds.
Yeah, we'll do that. Yeah, I agree. So t to equal to 1. And the 1.5 is actually a triangle of negative area only we want, right? So I'll simply write the area.
That means half into base into area we can calculate using this one.
Yes. Half into 0.5 into 1.
Yes, sir.
Okay, so 0.5 milli plus.
Last part in ampere, right? first 0.5 milliampere, but in the last part in ampere. Because L, yes, in ampere.
Yeah, that is in amperes, but the time is in milliseconds here. That's what you have to remember.
Okay.
See, this time scale is in milliseconds.
But actually, it is divided by L. That means L in also given milli.
Fine. Whatever. No problem. L is still there. We'll get whatever we get. Don't worry.
Okay.
Okay. Sine. What is the sine pi? What is this value?
2 Vm by pi. Vm is equals to 1. That means 2 by pi for half period.
Why do you say 2 Vm by pi?
For a sine curve, half area, we can also integrate it, and by putting the limit, we can also
correct. I think you're right. 2 by pi, right? That's what you're telling?
Yes, sir.
2 by pi minus 0.25 milli.
Yes, sir.
Okay, whatever this answer boils down to, I don't know what it's going to become. 0.5.
But actually, sir, if we calculate by putting L, I am getting 387 point something milliamp.
I think this is 1 second. 2 by 5, 1 by L is 1 milli. 0.25. Yeah, this is right. 0.5 milli plus 2 by pi 1 by milli minus 0.25. This is the answer, right?
Sir, 2 by pi into what is that?
1 by 1 milli. 1 by L
1
value.
by 1 milli. That means that part in ampere, right?
Yeah, this is what dominating the answer is.
Yes. But so if we calculate it, it's very easy. 2 by pi is 0.63.
Yeah.
That means 630 milliampere. And 0.25 ampere, that means 250 milliampere.
Yes.
And the answer is 387 point something in milliampere, and it is asking milliampere in the question.
Okay. What is the answer given there?
It is given in the range 0.62 and 0.63.
Okay, I'll correct this. I'll ask them. This is the assignment one. Which question?
Assignment 1, question number 14. 1-4.
Yes. See, in the correction, this is not taken care of. Recently, some corrections.
No, till now it is accepted answer in between 0.62 and 0.63.
Okay, sure. Question number what you tell? Question number
14. 1-4.
Okay. Great. Thank you so much. I will take care of this. Okay.
Thank you, sir.
Okay. Any other questions you have?
No, sir. Till now it is okay.
Thank you so much. Okay.
Sir, when we will meet next?
Monday, same time.
Okay, sir. Thank you so much.
Okay. Thank you. If there is a change in time, we'll inform you. Okay. Mostly if they same.
Okay, sir.